Ladies and gentlemen, welcome to the newest episode of the Efficiency Equation. This is episode 14, so we're on a roll here. We're usually talking about bulk liquid manufacturing in this show, in fact, almost always, and this is going to be no different. So today's going to be no different, but what we're going to talk about are very much solid pieces of equipment, namely storage tanks, right? So bulk liquid manufacturing has this peculiarity that liquid needs to be stored. And when you store product in liquid containers, storage tanks, things can take interesting directions. So this is what we're going to discuss today. And I am, again, very happy to welcome Eugene and Konstantin to the show. Welcome, you guys.
Thank you very much.
Thank you.
Let's dive straight in the middle of the thing. What are the current challenges in bulk liquid manufacturing as it relates to storage tanks?
Well, that one is very simple. Whoever you talk to, they'll say that there are never enough storage tanks. I'm talking about companies, plants that have over 100 storage tanks. So these massive facilities by any measure. And people there will still say that they're sometimes short on storage tanks. And that has to do with inefficient use of tanks and planning issues. Then you have plants that have less than 100 tanks. So maybe 20, 30, 40 tanks, and they will complain that they don't have enough storage tanks when they compare themselves to those other bigger facilities. And there are some places that have near zero storage tanks, and they will complain when their bosses ask them to use temporary storage solutions like rail cars, trailers, there are tanker trailers, or ISO tankers. And so when you have this temporary solution, it has its own range of challenges. And so through all of these different arrangements, people will always complain that they don't have enough storage tanks. One thing that's in common with all those places is that to make sure that you have enough storage tanks, you have to have visibility into your production processes and into your planning. And then you also have to have visibility into actual and planned inventory in your tanks, in your storages, so that at any point in time, you could quickly say what you have on hand and what you're planning to have in those tanks in the next few days. Of course, one thing that you cannot do without is careful planning of production. So yes, almost all of these plants have production planners busy and thinking that they got everything under control. But when you plan, you have to anticipate changes if they're likely to happen. You have to anticipate delays and plan for contingencies.
And is there anything special about the challenges that these manufacturers face when compared to other areas of manufacturing?
Absolutely. Since we're talking about specific use of storage tank in specific industry, we going with liquid bulk manufacturing. So we're storing bulk liquids in the storage tanks, or something that is very similar in behavior and physical attributes as the bulk liquids. We can name a few categories that fit into that description, such as foods and beverages and oil and gas, chemicals of different sorts. The problems that are associated with this type of storage tanks usage by these industries is different and special in terms of how it differentiates from discrete manufacturing, right? When you assemble products from different parts, you do not have the same issues as it relates to storage tanks. You have parts in warehouses potentially, but you can easily, let's say, examine the parts for defects, right? Which you cannot do if you're talking about some kind of liquid or liquid similar product in a storage tank. Visual inspection of the tank, it may give you some idea that the tank is broken or something's wrong with the tank, but not really with the product. Normally, the product will look fine, but it doesn't mean that it is. So visual inspection is usually not enough. Then you have issues of mixing liquids or substances of liquid-like products. When you have something in the tank already and you put something into the tank on top of it, potentially the same product, but that same product is not exactly the same, right? Because it's a liquid. So it would have slightly different chemical characteristics. So now when you mix the two, what do you get? you get some kind of a third product, which is a mixture of what was in the tank with what just came into the tank. So that complicates things again, and you basically have a new, what we call lot or batch of the product, because you had something, now you added something in, now you get a third thing, right? It's a mixture of the two. That's a specialty that you have to deal with in the liquid storage like that. Lot traceability is another issue, especially when you have tanks that are used as a throughput tank. Basically, you going into the tank with the product at the same time as you're going out of it. If you imagine that, how would you be able to trace what's in the tank in the given moment? What's mixing with what? You have to almost treat that tank as a pipeline, that it's not really a storage if you have both ends of the tank potentially open at the same time, product coming in, product going out. Your level will never be true because you really don't know how much is in the tank, because the tank is continuously being used in and out. So it's almost like you're not using it. Potentially, if you're coming in and going out with the same rate, the level stays at the same place, right? And nothing changes, but in fact, the product is flowing through it. So there are challenges like that that are very specific to bulk liquid manufacturing or similar manufacturing facilities when it comes to storage tanks.
Do you have any examples of these issues that you're describing?
I'll give you 3 examples. One, it was a facility we work with where there's over 100 tanks and they have just-in-time production. Sometimes production planning is done without capacity planning or considerations for plant capacity. And what happens is, if you have a few customer order pickup delays, the product stays in those storage tanks that it was supposed to be out of already. And then whatever is following it in production cannot proceed. And so in those situations, you'd normally expect that there is some contingency where if you can't go to this tank, you'd go to this other tank. But if that happens at the same time on the same day, such that multiple customers delay their pickup, or it's the carrier that didn't show up on time, it might not be anything to do with the customer themselves, then your tanks are backed up. And then what you see in that kind of facility is planners begin to issue instructions on different lines of equipment that say, stand by, tanks full. So they're filled and they're waiting to get rid of the bottleneck. So that's one example, and that happens periodically. And then I'll give you another example at a different facility where there's less than 100 tanks, and then they produce to stock, and production planning is done up front, and the planner releases the schedule for a week and then may not look at how the production proceeds for a few days. And then what happens is there are quality issues with the product. There may be rework that isn't identified as rework, and we've talked about rework in our previous episodes. In the end, what happens is the planner had allocated a set amount of time for all the work to be done, but because they're reprocessing, they're keeping the tanks, the storage tanks, in use longer, and everything that's behind it is delayed. And the planners will not find out for a few days that everything they scheduled is like a few days late. So that happens. And then a third example of a facility with almost no spare tanks to store anything. We're talking about production to stock, and ingredients are brought in for the soft drink production in ISO tankers and staged outside the facility. And they're supposed to wait for their turn. And when the production operators free up, they take them, put the ingredients into where they need to go in the facility, and they move on with the process. Now, what happens is there are quality issues with the product. Not the one that just came in, but the one that was previously being worked on the production floor. And so they're delaying the moment when they can take in the newly arrived ingredients from the containers outside. And what happens then is, oh, by the way, that facility operates in a place with a hot climate. So if they're late a certain amount of time, and in the case that we discovered, they were late by a few days. In those few days, whatever stays in the ISO tankers outside may just perish. And it did. And so now They cleared up the jam that they had with the previous production campaign. They go outside, they look at what they got, and they can't use it. This is another example of where having storage tanks readily available to keep the product moving and to keep it stored in proper conditions is very important.
How do bulk liquid manufacturing companies do this right?
To start off, you have to plan your plant's capacity and potentially invest in at least the minimum required number of storage tanks so that you have something to play with, right? You need to invest into SCADA systems, supervisory control and data acquisition, to make sure that you are tracking your tanks with some automation, with sensors. You want to make sure that you have an MES system that can provide you a more advanced tank inventory, not just a picture in time, as SCADA will give you, right? You can always look at your controls and see what levels or temperatures are in the tank. But with proper MES system, it can give you tank inventory into the future with accounting for the planning, right? So the planning instructions that you put together, they will consume and produce a product which will affect the tanks and the levels in the tanks going forward. If you have that, then not only you are capable to look at what my levels are now and what is available and what is not, but also into the future, and which is a very important part of planning and efficient use of your storage tanks. Once you do have everything in place, you need to maintain discipline in how you use your systems and how you use your tanks to make sure that everything runs smoothly. So as you keep your systems in check and you maintain your discipline when using them, the next thing to do is to keep watching out for proper data so that you don't have anything bad, because as soon as you have bad data, it starts snowballing. And if you don't attend to it quick enough, you end up with more and more work, potentially in geometrical progression, that you just don't want to or can't unwind anymore without like a hard reset of some kind. To avoid that, you have to continuously looking at and checking to make sure that all your data looks good and proper. You also have to plan for contingencies, right? Because things do go wrong once in a while, and you have to make sure that you know how to go around those things that normally happen, at least those, right? The ones that you can expect to sometimes happen and cause delays. You want to avoid that. You want to have a plan for it. You want to have a plan B when you just run out of storage capacity and you don't have any more tanks to spare. You want to have plan B for your floor production as well, because they don't want to get stopped by the fact that you have no storage tanks and just leave the ingredients waiting outside in the heat. Is just not good for anything, not good for anybody. You need to have, at least some sort of a plan B, how you're going to act when something happens that normally doesn't. So all of those things together, that's going to help you do things right.
To add to that, in answering the question of how can the plant managers do this right, I would call for asking why the quality issues happen. So first of all, as you look at the different stages of your processing, you need to ask the question, do you make quality checks at the end of each stage? And do you have proper gate checks? Are they working? Where you say, if the end result of one of the stages was not good, it didn't meet the spec, is there a possibility that your production operators are still going to continue on to the next stage? And if they continue, sometimes they're able to fix this later, but most of the time you will have the snowballing effect in that you've produced something that wasn't what you intended to produce. And if you're lucky, you may be able to say, oh, this is just now a different product. But a lot of times you'll just have to reprocess all of that. So you need to make sure that checking at each stage is done properly and that there is a handoff where you say, okay, now this is good, keep moving forward. Now, after that, you would need to track your right first time metric, because it will tell you which of the products and which of the production lines are your problem areas. Where do you have issues most of the time where you can't make this thing right from the beginning? Also, OEE, overall equipment effectiveness. A lot of places that we see don't track the quality component as well as they should have. So rework is underreported. A lot of times people would just not acknowledge that there is rework. So the quality component of OEE tends to be inflated. And I'd say if there's greater emphasis on doing OEE right, yes, your OEE indicator will be lower, at least initially, but that's what we're after, because when it's lower, it will cause the plant to place greater focus on it and figure out what's causing this, right? Go after rework aggressively. That should be a mindset change, because if you allow people to say that rework is just part of normal adjustments that we make all the time, that masks rework. And that is what causes your delays, and that is what leads to storage tank shortages, the capacity shortages. So you need to invest into systems and enforce quality checks at each stage. Then plan production. After you have quality taken care of, you need to do your production planning in tandem with capacity planning. So if you know how much your plant is supposed to produce under normal conditions, you should stick to that. And don't overpromise. Do not overcommit yourself when you have customers asking for multiple things out of the blue, because what happens then is you say, yeah, I think I can fit it in. You fit it in, you fit another one in, and then some other client doesn't pick up their product in time, and now you have gridlock. Now you have this issue where your tanks are full again and you cannot produce, and now everything is waiting. So that's important. And if you have a dip in demand, you need to keep the pulse check there. You need to know that this is coming, so that you do not overstock raw materials that then also need a place to be stored at, and you don't know when they're going to be needed. So it might as well just not be there to begin with. This one is a little harder. When you have a dip in demand, you need to check for it proactively that it's coming, and then reduce your stocking levels. So that's, in a nutshell, a long answer to the question of how do they get it right.
So Konstantin, you mentioned investing into systems. Now, you also mentioned investing into tank level sensors in previous episodes. So you've specifically called on plant managers in episode 13 to invest in these sensors. Now, according to your experience, how bad is the situation right now?
This is going to be subjective, because this situation differs across different industries, and it's very, very hard to find precise data that would cover everybody, because some plants just don't reveal what they have. So there are some estimates on the internet in different assessments, and what we've been able to see is that industries like oil and gas and chemicals, they are doing a little bit better than some other ones that use the same type of tank storage. So there, the estimate has been that at least 25% of existing tanks in US and Canada are still the old tanks that do not have automated level sensors. And what that means is that there either may be manual gauges that show the outage, and that means that people actually have to walk up to them to take the reading. And the other option is that there might not even be the gauges, and that means that the tanks need to be dipped. And you have other industries, food and beverage, edible oils, there it's worse. You would have estimates that tell you that over 50% of existing storage tanks in the US and Canada are still the old tanks that don't have proper automation. Just think about that. All this food we buy and eat, there are people behind 50% of those products that walk up to these tanks and check what they have on hand manually. And that takes time. So you got time and loss of accuracy when that happens. In soft drink manufacturing, it's less than 50% that are still old, but there is still a relatively high number of those tanks at facilities that are not fully automated and their tank level sensors aren't there. When you look at this, there's plenty of opportunity to just invest into having those sensors. And sometimes people don't get it. So I want to reiterate why it's so important. When you have the tank level sensors, you normally can push a button or make a few clicks and you have your levels, your inventory for all your tanks at once. You know what you have on hand, assuming, of course, that everything is working. If you don't have that, and if you have to send out a person to look at the manual gauges, they will come back after some time, and it will take them a considerable amount of time during which the plant does not stand still. The product is moving. So anytime you're sending anybody out into the field, you end up double counting product. And if you have the dipstick situation where the tanks need to be dipped, just picture this. These tanks are huge. So usually people have to get to them. In some cases, they can get to the upper level using some ladder on the side, and then the tanks are interconnected and they can walk around at the top level. But in some facilities that we've seen, they have to climb the ladders. So all that climbing and dipping the tank, that takes time. There is a facility we've seen where taking inventory manually like this may take up to 6 hours. If you think about it, during those 6 hours, there is constant movement because the production doesn't stand still. So they're pumping product out of one tank, they're doing something to it, they're sending it to another tank. So if you started at tank, let's say number 1, and you're finishing at tank number 60 or 70 in 6 hours, everything you just got is not right. You can say that within those numbers you have several places where the numbers are just wrong because the product was moving, and you're going to come back and you're going to say, well, as of right now, maybe it's 12 noon already, this is what we've got. And it's not right. That's not what you got. That's why it's so important that you need to be able to get your inventory just like that, because it keeps moving. Nobody is going to wait for that person to take inventory and not produce anything while they're inventorizing. So that's the key here.
Okay, and what about the temporary storage solutions such as rail cars and tanker trailers, ISO tankers? So can they really be used as permanent storage?
Yes, of course they can be. We've seen all of those being used as such, but there are specific issues to each one of those and potentially others that are maybe used like that. For example, if we take rail cars, right? Rail cars, while they have decent size, right? They have a lot of capacity you can store a product in. They are very slow to move because first of all, you need rails, right, to move them on. You need some kind of vehicle that will move that rail car around. Usually plants, have a local vehicle that pulls the cars, but still it's a long process because it's hard. You need to switch the rails from this to that. It's just an involved procedure. Plus, the rail cars usually don't have any type of heating source. You have to heat up the product that's in the rail car in many cases, if it's some kind of liquid that might be solidifying at normal temperatures. So it's not just slow to move, it's also slow to use potentially, right? And the throughput at which you can pump the product out of the rail car is a hose, right? It's not a pipeline. It's not as efficient and fast as it can be with a solid pipeline. There are many things like that that complicate the use. Also, when you have those rail cars on your site, it's like one rail car is a big thing, right? Rail car is a massive vehicle, right? You can potentially have only a couple of spots on your rails where you can actually offload the rail car. But imagine if you have 10 rail cars, 15 rail cars, 20 rail cars somewhere around on the rails. Now, trying to move them into position where you can actually use it is another chore, right? All of that complicates the use of rail cars. That's the rail cars. Now, if we go to tanker trailers, right? That's your usual trucks with a trailer behind them. Yes, they are easier to use than rail cars, right? Because you can maneuver them quickly enough compared to rail cars. You don't need rails. You just need a truck that can, hook up the tanker and move it around. Much more nimble to move around, potentially has the heating in place already, so you don't have to use like say steam with rail cars to heat up the product. The trailers can be hooked up to some electrical source where you can heat the product that way, so you're much more efficient with that. Again, it's not as efficient as having real storage tanks, but it's better than rail car in terms of how fast you can move the product around and how fast you can use the product from the tanker. However, the tanker would be 3 or 4 times smaller than the rail car, right? So the capacity of that tanker is not as great as the rail car, right? So you have this kind of problem. And of course, neither railcar nor storage tankers is your scalable type of storage. It's okay potentially for an off-case use here and there, but not something that you want to rely on continuously during everyday operations, because it's just not efficient. You can also use the ISO tankers, of course, as storage tanks, but you have pretty much the same type of issues as you have with rail cars and tankers, trailers. It's like a combination of the two because they don't move by themselves. They need to have some sort of a chassis on which they would stand. You also need to be able to heat them up. Usually ISO tankers do not have heaters, so you would have to think about that, how to heat the product if the product needs heating, of course. If it doesn't, maybe you can sidestep that particular thing. So overall, yes, they can be used as temporary storage. They're not efficient, so they don't scale well. If you do something that goes in and out frequently, they're not a good solution. They just complicate things because of the logistics that is involved with moving the actual physical tanks, be that rail car or tanker trailer or ISO tanker, around the facility. Where the storage tanks, they just built and they stand in place and they don't have to be moved around. They piped in and off you go. So yeah, it can be used for sure, but it's not an efficient way of storing product.
You mentioned the need to track actual and planned tank inventory. Can you explain more about it? Why do you need planned inventory?
Actual inventory is pretty straightforward to understand, right? So we just talked about the sensors. If they have them, you need to know what you have on hand. Now, planned inventory takes it a step further, and this is a critical point of differentiation between the different solutions that are used for this, because the planners don't plan for right now. They sit here today, every day, and they plan for some time out into the future what they're going to produce, right? So they may be planning 3 days out, 5 days out, 2 days out, whatever the circumstances require. Now, when they come in and look at what they have, what their situation looks like right now, they can look at the actual inventory if they want to and say, oh, I have so much of this product in this tank and so much of this product in this other tank. So now I have a customer order or inventory order that I need to fill. Where am I going to get the product from to fill that order? And then they look at their tank inventory. The trick is that whatever they just saw in their actual inventory might already be committed to some other work orders. So how do they know what tank it's okay to take from and what tank it's not okay to take from? So what the planners in this kind of industry do is they keep a tally of all the ins and outs for each tank that start with the actual tank inventory and then the planned input, planned output. So they might be planning to take some away for production of something, and then they might be planning to bring some new product in. So from actual, they have all these ins and outs. And years ago, so maybe 14 years ago or so, we were working with planners that were doing this by hand on paper all the time. And what ends up happening is if you do this without automation, you are constantly having to update this. So this becomes something that consumes a lot of time every day. You're always looking. It's okay if they want to just do some kind of sanity check with a pencil and paper. It's up to them. But normally that needs to be done by the system, because if the system does it, the planners have their time freed up. They don't have to sit there and scribble and do the math all the time. I'm taking 50 from here, I'm adding 50 to that other tank. And then once they have that tally for 3 days out, for example, then they can look at that and say, oh, what does my tank inventory look like 3 days from now? Will I still have uncommitted product in this tank that I can take and use for something else? So that's what happens there. They don't really do all of the planning with whatever they just have in actual inventory. It's always actual and then the planned ins and outs. And then at that point, what do I have? So to have all of these planned ins and outs under control and to be able to see that quickly, of course, you save a lot of time and you increase accuracy by having the system do that for you. But that's where I said it's a critical differentiation factor between different systems, because there are a lot more systems that will just show you what you have on hand. Everybody understands that part. But to be able to show you what you're going to have on hand 3 days from now you're talking about not just automating readings from the tank level sensors, but you're talking about integrating all that with the production scheduling software. So your tank inventory and production scheduling software, they go hand in hand.
Right. And you mentioned having to maintain discipline in using the systems. And how so?
The tank inventory data is what we are ultimately after when we're using systems, right? And the data will show us all kinds of things as to how overcommitted or undercommitted we are. It will be used in financial reporting, because you will need to know what your inventory is for finance. So maintaining discipline and using these systems will get you to better data. There are times that things happen that are not recorded in the system one way or another. It obviously depends on the level of integration of your systems into the hardware and into the actual process, but usually there are issues that could come up that don't get recorded in some way for some reason. It's always a good idea to actually get back to the systems and record everything that happened that might have skipped the monitoring by those systems, and let the system know that it actually did happen. Again, this will prevent the snowballing of bad data, right? You want to make sure that the system is as aware as possible of everything that's going on with tank inventory, with product movements around tanks, and so on. Sometimes tanks may malfunction, meaning a sensor is malfunctioning or a pump is malfunctioning or whatever it is that makes the data accurate about the tank is just out of order in some way and requires manual intervention, even when everything's automated. With that, you have to make sure that if you know that there is a problem, that you keep a good eye on it, so that whenever you need to correct something, you do that timely, so that, again, there's no snowballing of bad data in the system. And inventory usually is taken at certain times. You can take it once a day or many times a day, and that data needs to be clean and as accurate as possible. Again, the usage for that is very wide across the company. We're not just talking about planning and production here. We're talking about financial situation of the company. At any time, you may want to know how much product we have and of what kind of product, because it's financially important to know for the company. All of those things are possible if you have good data, and to have good data, you need to maintain discipline in how you use the systems, right? Some tanks, for example, may be involved in some activity nonstop, and it's very hard to keep inventory for such a tank that is constantly being used. So you need to make sure that you are aware of that situation, if you have it, and that you do update the levels on those tanks that could be problematic. Say you take an inventory at 7 a.m. in the morning. Just a number, right? Well, okay, maybe 95% of your tanks at that time are not involved in anything. And it's great time for you to take the levels across the inventory and say, yep, I know my inventory now. Well, what about some other tanks, maybe 5 tanks or 2 tanks or 3 tanks that are being involved in some production run or transfer of product or something, right? Taking levels at that time is kind of inaccurate. right? Because they are in the tanks are in flux. You don't really have a good picture of what's going on at that point. If you know that, you can keep an eye on it, and depending on what system you use, the system may be able to keep an eye on it for you. And it's like, okay, I know it's being used right now, so I'm going to take the inventory a little later for this tank because of the fact that it's being used. Or if you don't have that, you do that manually. You know, like, okay, this tank is being used right now, so I want to make sure that I take the accurate reading after it's done being used, or whatever the most appropriate timing for that would be. Again, to have good data to prevent snowballing effects of having bad data. Making sure that you have all those sanity checks performed by trained users that know what they're doing, that know what they're looking for, and keeping good maintenance of systems and tanks themselves to make sure that you don't have unreported issues that go unchecked. That is the goal here, to have that good discipline will help you achieve.
Yeah, you mentioned the need to have contingencies around critical delays. Can you comment on that?
I'm thinking about a particular plant in this example where you have production, just-in-time production, and you can analyze how frequently the carrier comes late for certain pickups, or how frequently certain clients, certain customers send their preferred carrier to pick up and it's late. And what that does is then that allows you to create a plan for what to do if they're late again. So if you have somebody that's consistently late, you can account for that time, create yourself a buffer, and do not overcommit resources, do not overcommit storage capacity. How many of the plant managers today can tell me with their existing tools, whether they are on paper or in the systems, that they can analyze the delays with which their orders are picked up and adjust their schedule and adjust their storage capacity to account for those delays? That's very important. That's what I mean by planning for contingencies. Always count on having delays. And it's one thing just to know, oh yeah, that might happen. It's another thing to be prepared for it, to have that extra storage capacity to go to. And what does that mean? That means that there's always a cost. Planning for contingencies costs money. There's no secret in that. However, if you have the right tools and you have the right systems to help you with this and bring transparency, it will minimize that cost. And if you think that, oh, if I just don't plan for contingency, I will not incur the cost, you will incur it later when everything comes to a standstill and the planners are issuing standby tanks full instructions to your production operator. So the cost is there. It's just elusive. You might think it's not there. It's going to come out later on. But if you want to minimize the cost, you invest into the tools, into the systems that bring transparency into this. And then you still have to be careful with committing that storage capacity.
You mentioned looking into quality issues. Can you expand on that?
Certainly. As we discussed before, quality issues could be a leading contributor to production delays, and production delays obviously lead to shortages in storage tanks. So all of that is tied together. Quality has to be looked at as one of the main concerns to make sure that you have it in check. You potentially want to make sure that every time you have production phases going from one tank to another, from product being used in some kind of process inside the plant, and it's being taken from one tank and moved into production process and then coming out of the other into the other tank, you want to make sure that at each such stage or phase, you do quality checks. And before taking the product and moving it into production, you want to make sure that it's approved for such movement. It depends on the systems and software systems do you use, whether or not they provide such visibility. It's always a good idea to have that, so it can help you maintain your awareness of each individual tank and their QC status at any given time. Making sure that you track right first time metrics, not just to say, oh, we're great, or put a badge on your chest, but the actual knowledge that comes out of it is you can analyze what products cause most difficulties for you. And then when you know that, you can address specific issues that relate to those products and to delays that they cause. Usually they can be addressed much more efficiently because you're not just taking a problem head on as like, okay, we have a problem across the board. No, you can look at specific products because you know that they are the ones causing most of the issues. So why is that? And you can address those much more effectively when you have specific data. Start tracking OEE, right? Because that's another component in all of your metrics that you do. That's very important. OEE itself has a quality component to calculate the OEE. And in many cases, manufacturers neglect the quality component. It's understandable. It's not always easy to calculate, but it's something that the plants should try to do and be accurate and truthful about it. Do not underreport anything, especially the rework. You want to make sure that you address it truthfully and honestly for your own good. It's not about trying to punish anybody. We're trying to improve here, right? We're trying to make the process more efficient. So underreporting is just basically hurting your own self. You don't want to do that. You want to attack rework monster, as we called it before, head on. You do not want to accept that we just make adjustments and that's normal part of our production. It usually isn't. If you have to make those adjustments periodically, frequently, and consistently, it's now really masking the fact that you are reworking something, right? Maybe look at those processes, adjust them so that the number of your corrections goes to 0 or sufficiently decreases. Again, that will make your costs go down because imagine that you have a product in the tank that sits for a while. You have to keep maintaining that product in the tank from every perspective, potentially having some additional materials or electricity to actually keep up the product in good shape in that tank, doing periodic QC checks to make sure that whatever's in the tank is still in good shape. All that is cost. So proper planning of tank capacity and making sure that the product doesn't stagnate in the tank and keeps moving, that reduces overall costs and eliminates bottlenecks and avoids delays. So all of that together, though, is basically a mindset change, right? You have to be mindful of all these things, how quality impacts everything, go after rework aggressively, and that will help you improve your business and overall efficiency in it.
Wow. Well, we have discussed a lot of things. What is the one thing that plant managers should focus on out of the gate?
The first thing would be the mindset change. Be truthful about your situation, your results, and strive to improve them. And you know, the old saying goes that the first step to solving a problem is acknowledging that you have one. And whoever thinks they don't have problems in their production, they should probably be replaced by those who are eager to improve, right? And then I would say mindset. After that, partners. So pick the right partners in helping you to solve these issues. This could be consultants, system integrators, software vendors, internal employees. That doesn't matter who it is. What's important here is the long-term focus. You want to work with people who are willing to study the ins and outs of your business and make sure that the solutions that are put in place have the long-term focus so that you don't have people who just patch something and run away, and then in 3 months you never see them again because you will have to fix that patch again. So you want long-term focused partners. And then the third thing is overall invest into training your employees, empower your employees. And when you do that, you then ask them to make recommendations for process improvements. If you get the culture change such that your plant floor operators eagerly come up with suggestions on how to run things better, that's it. That's your main competitive advantage because those people at the shop floor, they have lots of ideas. They may not be motivated at different plants to tell you what they think needs to improve, but they see it every day. So they have the best ideas. You just need to get them to speak up eagerly and own the process, own the business, always act like they're business owners, and this will improve things. And then lastly, of course, you want to look at taking away unnecessary work and investing into systems that can do the mundane work for you and free up your people for better and more important tasks. I think those four are key: mindset, the right partners, training your employees, and investing into automation and systems to free up the time of your employees.
Ladies and gentlemen, that concludes episode 14 of the Efficiency Equation podcast. We hope you've enjoyed it. We have covered a lot, and thank you for sticking around, and we will see you next time. Bye-bye.
Bye-bye. Thank you.
Bye.